Hey, student journal here. I want you guys on page 49 right now. You're going to we're going to start talking about algebraic properties to solve equations, which is going to help us get into starting proofs. So I want you to work on page 49 with your groupies. Take a few minutes to do that now. All right. Hey, ladies and gentlemen, need your attention up here. It says, work with a partner. In the previous courses, you studied different properties, such as properties of equality, distributive, commutative, associative properties. Write the property that justifies the following solution steps. Okay, so they kind of give you some hints there, but first you need to know your properties of equality to be able to do this. If you're looking at this first one, go ahead and tell your neighbor what they did to get from this step to this step right here.
Oh, did you write what you did? Yeah. Oh, that's easy.
Okay, what property we got?
Distributive.
Yeah, distributive. Okay. All right. Now tell your neighbor what they did from here to here.
They grouped together. Is that what it's called, grouping? Is it called grouping? No, I don't think it is. I mean, you're grouping together, like...
Yeah, kind of. Okay, so I'm going to pause you for a minute. I want you to go ahead and turn to... Let's see if it's in your student journal real quick. Thought we have it. Yeah, turn to page 51 of your student journal. 51, so skip 50 for a minute, and this is going to help you out. Now, using those properties, they did one of those properties for step 2. Okay? So reference those properties on page 51 to help you complete the next step there.
Addition property. No, isn't it subtraction property? No, not subtraction. It's subtracting. No, because 6 minus 5 is 1. Subtraction property.
Okay, so they are combining this and this, right? Most of you just say that's like combining like terms, right? Okay. We can actually write that. Combine like terms, if you spell it right. Combine like terms. I kind of jumped the gun there. Here is where you need to use one of those properties. So what are they doing on this?
Oh, what?
Yeah, they're subtracting the same value from each side. We call that which of those properties? Mr. Drew. Yeah, subtraction property of equality. You guys have just said, yeah, we subtract the same thing from both sides. Okay, we're actually using the subtraction property of equality. Okay, go ahead and talk about those next few there. What are you doing? Use those properties to help you out.
You already do the subtraction. It's like division?
All right, let's check them. Next one would be combine like terms again, right?
Oh, well, yeah, I guess.
Combine like terms. So we're putting these two together. We're combining. We then, to solve this equation, we'd have to subtract 4 from each side. When we subtract the same amount from each side, it's called subtraction property of equality. Okay? So after you subtract 4 from each side, you end up with 3x, because 4 and negative 4. And you have to do 1 minus 4 to get negative 3. What's it called when you do this? Not doing a property of equality. Property of equality, you're doing the same thing to both sides to make it equal. When you're just putting like pieces together, what are we doing? Combining like terms. Okay.
Next one, division?
Next one, we're dividing the same amount. So that's a property of equality. What property of equality? Division property of equality. Okay. Now if we do that division property of equality, really all we're doing, we're simplifying here. We're not combining like we're just simplifying. So when you're doing the math, you're just simplifying on that side. Okay? And finally, the symmetric property of equality. Symmetric property of equality we haven't spent a lot of time on. Okay, we'll actually talk about it a little today. Symmetric property of equality just says, hey, if this equals this, then its mirror is the same. Okay, you just flip it around. Danica. Here? No, you're not dividing by -1. You're just flipping it around. If we divide it by -1, you get positive. Right? Okay. I want you guys to take a look at example or exploration 2, the next page. There it is. A bit different now. Right? Okay. Get a couple of minutes to work on it. Use the properties that we talked about plus the ones on page 50 or 51 to help you out. These ones here. Okay? All right. Go ahead and work together on it. Do your best. Get a couple minutes. All right. Hey, guys. I realize this is kind of tough stuff and almost feels like I'm trying to trick you. But really, what you're doing is you're reviewing tons of properties of qualities here. Or tons of different properties that you haven't talked about for a while. So if I'm saying 5 times 6 equals 6 times 5, is that true?
Yes.
Anyone know what property that is?
Symmetry.
Does it matter what order you multiply in?
Symmetry.
Moonty? It is not the symmetric one, no. It is kind of, I guess it does look symmetric. Yeah, I understand what you mean there. This is actually called the commutative property when you're dealing with operations. How many of you have parents that commute to work each day? They commute. They go to and from. This would be the commutative property. Now, if we knew like the symbols diamond and circle represent addition and multiplication, not necessarily in that order. Okay? Well, if we knew it was commutative property of, if we knew that was multiplication, it would be commutative property of multiplication. Can you add in any order?
Yes.
So like does 5 times 6 equal 6 times 5? Yeah. Does 5 plus 6 equal 6 plus 5? Yeah. So you have commutative property. Commutative property could be addition or multiplication. We're not sure which one in this one because we don't know what symbol stands for what yet. Does it?
Not necessarily.
Later on, I think we might be able to find out. Oh, it does say determine it first?
Yeah, it says determine which symbol represents which operation,
Then state it. How can we determine that? Yeah.
So Isaac says, so when you get on here, it says 0 diamond 5 is equal to 0. So that would be like 0 times 5 is 0. And the next one is 0 circle 5 is equal to 5.
Good. These tell us right here. Very good. Well done. Yeah, Isaac, you look like you're doing the Seahawk flap, man. That was awesome. Hey, you're right. So that means diamond represents multiplication. Circle represents addition. Okay? Just so you know, these properties down here are called the zero product property. It means if you multiply anything by 0, you're going to get 0. Okay? And then this one right here is called the identity property of addition. It means if you add anything or 0 to anything, you get what you started out with. You get the same identity. So very good. You're supposed to, it did say that. It said then state it. So you had to do that first. So this actually up here is actually multiplication. Seriously. That's what's that. What did I say? Oh. All right, what's this one? Commutative property of addition. Anyone know what it means here? They're just moving parentheses around. It's like the 5 and the 6 are the hanging out, and then the 5 goes, no, I don't want to hang out with you anymore, 6. I'm going to hang out with 4. 5 is associating with 6, and then, okay, this is called the associative. The associative property of what?
A multiplication.
The multiplication. And so what's this one?
Associative property of addition.
Good. Associative property. Oh, we better not abbreviate that. Property of addition. Okay? Doesn't matter if you multiply 5 by 6 and then multiply it by 4. It's going to be the same as if you multiply 4 by 5 and times 6. 5 times 6 is 30, times 4 is 120. 4 times 5 is 20, times 6 is 120.
So the parentheses don't really even matter in that case?
Not when you're doing straight multiplication. Same thing with straight addition. That's 11 plus 4 is 15, and here is 9 plus 6 is 15.
Why do they even have it?
Okay, what's this one right here? This is called the identity property of multiplication. You multiply by 1, you get the same answer. Identity property of multiplication. And last but not least, what did they do here? It's one that you do all the time, man. Yeah, Hunter? Yeah, this distributive property. Right. All right, so you've looked at some of these properties on page 51. Okay? The algebraic properties, the addition, property of equality, subtraction, multiplication, division. There's also substitution. If A equals B, then A can be substituted for B. You've done a lot of that. Cynthia? This is not on your quiz tomorrow, no. Only through 2-3 on your quiz tomorrow. Okay? I want you to take a look at page 52, though. Page 52 has a couple more properties called the reflexive property and the symmetric property and the transitive property. Reflexive. These are pretty, these are like duh properties, kind of, sometimes. Okay, maybe at least the reflexive. Reflexive says it says A equals A. B equals B. It equals itself. Symmetric is kind of your reflection. Okay? If A equals B, then B equals A. You can just move them around. AB equals CD, so CD equals AB. Transitive, you've done something like this. I'm curious if you guys will recognize it. Let's just stick with the real numbers. If A equals B and B equals C, then A equals C. What have we done that's like that? If AB equals CD and CD equals EF, then AB equals EF. Yeah, the law of syllogism. Yeah. Same idea, right? The same idea as transitive property. All right, so we have those properties I want you to reference today. Right now, I want you to take a look at your student journal, page 53, and I want you to work through, just kind of look at these, 1 through 3, in your student journal. Okay? Page 53 of your student journal, 1 through 3. Solve the equation. Justify each of your steps using your property. Hey guys, seriously, don't make this tougher than it needs to be, right? What's the first thing I do? Uh-oh. We forgot our algebra already. That's not good. Okay, subtract 3x. If I subtract 3x on both sides, what property did I just use? Subtraction prop of equality. You could abbreviate like that. Okay? Then keep going, right? You get 0, you get 2x minus 19 equals negative 7. Okay? And then your next step, okay, add 19 to both sides. What property is that? Addition property of equality. Okay, I'm not gonna make you say in between, yeah, well here you're simplifying and here you're simplifying. We'll do that, but explain your property. When I divide by 2, I'm
Division property.
Division property of equality. Okay. All right. Go ahead and try number 2 there. Come on. There's number 2. Distributive property, combined like terms. I said you didn't have to write the combined like terms. Subtraction property. Okay, twice, and then division property. Okay. Anyone do it a different way? Yeah, Brennan? Yep, you could. Yeah, if you would have moved them the other way, you could have had addition property of equality. Good call. Yep. All right, so the point of what we're doing is to be able to use properties to justify what we're doing. It's really setting you up for proofs, okay? Now, I'm not going to expect you to go through the rest of that page right now, all right? But if you want more practice on it, you definitely can. What I want you to do, though, is I want you to take a look at this problem right here. Those 3 problems. Name the property. These are monitoring progress. These are out of your textbook. Okay? Just really quick, using some of the properties that we referenced today, I want you to name the property of equality that the statement illustrates. Write them down. You can tell your neighbor however you want to do.
Property. And the next one.
Okay, which one is number 7? Yeah, Jeremiah. Good. Symmetric, right? This and this, they're like symmetrical, okay? If you were to draw a line here, you got symmetry, okay? This one is, Jordan? Reflexive. And if 1 equals 2 and 2 equals 5, 1 equals 5. That is, Drew? That's transitive. Okay. We good? All right. Very good. While I'm handing out your assignment for today, I want you to go ahead and try those 3.
Thanks. Shelby, what's the answer? How can you share 5 apples with 7 friends? Kill 2 of them.
Okay, what is number 10? Nathan, what do you got? Yeah, transitive. JK equals KL. KL equals 16. JK equals 16. No joke about it. Okay? How about 11? PQ equals ST, so ST equals PQ. Brennan? Symmetric. And then the same on both sides is? Reflexive. Okay, very good. Your assignment? The puzzle time. I actually have 2 examples I want to go through, but I'm going to save those for after the quiz tomorrow. Okay? Remember, 2-4 is not on your quiz. We will not be scoring this page until Wednesday. Okay? So your number 1, get this done by Wednesday, please.